So this is Unit 3, Day 4, or Day 3? It's Day 3. And today is September the 12th. Again, just saying that for people at home who are trying to find the right video to watch if they missed. Solving nonlinear equations and inequalities. So there's a lot going on today. Nonlinear, so that means not a line, so a little bit complicated. Equations, we know what those are, the equal sign thing. Inequalities, the less than or greater than stuff. It seemed like y'all did some of this last year, so we'll see how quickly we pick up on this. So first we'll do equations. Roman numeral 1 is equations. Roman numeral 2 is inequalities. So equations are a little easier to deal with. And we'll solve this kind of like we solved that problem we just worked on from yesterday. Like, I'd like to make the denominators go away. Well, I guess we should factor this first. I'd like to make my denominators go away. So I'm just going to multiply by the common denominator. And then I won't have any more denominators anymore. So this will go from a rational, ugly-looking equation to something a whole lot nicer looking. On the left side, everything cancels, or at least everything in the bottom cancels. So I'm left with 2x minus 4. Whoops. Plus, on the middle term there, the x minus 3's cancel. And so I'm left with x plus 3. And then on the right side, the x plus 3's cancel. And that leaves me with x minus 3. That was the pre-cal step. The rest of this is like algebra 1 stuff. Distribute, collect like terms, move things around. So let's distribute the 4, distribute the x. Uh-oh, an x squared showed up. So that means quadratic, that means factoring, maybe. It means set it equal to 0 so that we can factor, hopefully. So x squared, 2x plus 4x is 6x. If I subtract 6x from both sides, I get minus 9x. Negative 4 plus 12 is 8. So if I move that over, I get negative 8. Does that factor? It's like, it's sure tempting, right? Because 8 times 1 is 8, and 8 plus 1 is 9. But the signs are messed up, so it doesn't factor. Man, that's a tricky one to try to bait you into factoring. Well, if it doesn't factor, if a quadratic doesn't factor, what do you get to do? How do you solve a quadratic that doesn't factor?
Complete the square.
You could complete the square. I'm going to quadratic formula. Just because I'd rather sing than do all those half it, square it, add it things. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? Is that not the song that goes in your head when you do the quadratic formula?
No, that's like prehistoric.
Well, you got a more hip version of the song that goes in your head? Maybe I don't want to ask that. 81 plus 32. 81 plus 32 would be 113. Which is kind of an ugly number, but that's a good thing. That way I don't have to worry about reducing it, right? 113 is just stuck as is, so I'm good. Now, we kind of glossed over something here that we need to mention, and that is, I'm writing it in red because it's important, multiplying both sides by an x term multiplying both sides by an x term, something with x in it, might That's kind of an annoying word in a math class, right? Like we deal in things that work or don't work, but none of this might business. Well, we got a might today. Multiplying both sides by an x term might introduce extraneous solutions. Multiply both sides by something with an x in it, then you might get extraneous solutions. What does extraneous solutions mean? What does extraneous solutions mean? Doesn't mean imaginary. Doesn't mean complex. Okay, that's like imaginary that doesn't hit the x-axis. Extraneous solutions are answers you get that you didn't do anything wrong and yet they don't work. Okay, so it's like a glitch in the system. When you multiply by an x term, it might happen. And how you check it, first of all, you must check it, so you got to check it. But the good news is you don't have to check everything. You don't have to plug it in and do all of the work that would be required to make sure it works for sure. All you're really doing is checking to see if the denominator equals 0. Because if the denominator equals 0, you can't do that, so you have to throw it out. So the check is a really easy check. Especially, as terrible as that answer is, it's really easy to check to see if that answer minus 3 is 0. Like, no, I don't know what it is, but it's not 0. X plus 3 equals 0? No, that's not going to be 0. X squared minus 9, that's a little bit trickier, but that breaks into x plus 3 and x minus 3. Neither of those is 0, so we're good with both of these answers. So the big deal is you have to check, but the good news is checking is really easy.
Would we have to write what x can be, or is that only if the answer is a fraction?
That's only if the answer doesn't work.
I know, because what was the thing that we...
That's if you factor and cancel, then you say x can't be whatever you canceled. You don't have to do that here. Although that is sort of what that does tie into this. So like if we canceled the x plus 3 and the x minus 3, and so if you took a moment to say x can't be 3 and x can't be negative 3, those would be the extraneous solutions that we couldn't have. So that's the connection. So those would be the only problems that we would get. Number 2, kind of the same thing. Therefore, let's skip number 2 because it's the same type problem. Factor, multiply through. It also uses the quadratic formula, so let's pass on that. All right, nonlinear inequalities. This is a little bit trickier to solve inequalities because that inequality business, the negative, if you divide or multiply by a negative, it switches. And so that's kind of tricky. We're thinking above and below, open circles and closed circles. Like, there's just a lot more going on. So I'm going to write some steps down, but it's all of 2 steps, so it's not really that big a deal. Find all the zeros. And then just to clarify, all the zeros of the top and the bottom. So like you peek ahead, number 3 there only has zeros of a top. There's no denominator to worry about. Number 4 has more zeros, top and bottom. It's already factored, so finding them will be easy. And with those zeros, you set up a number line, and then you'll need to check intervals. With either, you get 2 options here. We'll check an interval with either the graph or a number line. The graph is easier, but you don't always know what the graph looks like. The number line works every time, all the time, very straightforward. Not hard, but if you know the graph, that might be easier. Okay, find the zeros, put them on a number line, and check the intervals. So number 3, finding the zeros means let's set it equal to 0. So move the 12 over. I think we finally got one that'll factor here. 2x and x. Let's see. If I put the 3 across from the 2, that'd be 6. That's not what I want. If I put a 4 across from the 2, that gets me 8. 8 and 3 can make 5. I want the 8 to be negative and the 3 to be positive. Well, I said 8, but I was looking at the... So I want the 4 to be negative because it makes a negative 8. Or negative 8x. Now, you can't just take the factors and set them, say both are less than or equal to 0. It doesn't work with inequalities. All you can do is set the factors equal to 0 to get the zeros. So x equals negative 3/2 and x equals 4. Alright, for this problem I'm going to do both the graph and the number line just to show both, and then you can kind of decide which way you want to go. So for a graph, well, I found my zeros. They're at negative 3/2 and 4. And what does the graph look like? What is that graph? It's a quadratic, it's a parabola. Is it pointed up or pointed down? Up, because it's positive. And so I don't need to be any more accurate than this right here. I found the zeros. I know it's an upward facing parabola. And I want to know when my, so another way to say this is when my parabola is negative. Right? Less than 0 means is negative. So my parabola is below the axis, all of this, that portion. That's the portion I'm looking for. Where is it less than 0? So it's less than 0. My interval would be negative 3/2, 4. Do I want to include negative 3/2 and 4 or not include negative 3/2 and 4? Why include? Has that line under there, the equal to sign. So I want to include negative 3/2 and 4. Let's do the number line. So it kind of looks similar. I'll put negative 3/2 and 4 on the number line. We already said we would include them both, so I'll do closed circles to make sure I include them. And then I need to check some values in each interval to see if it works or if it doesn't work. So I'll check negative 2 and 0 and 5. And when I say check, it's probably easiest to check into the factored form. Checking to see if they give me a positive or negative. So if I plug in negative 2, let's see, negative 4 plus 3 is negative. Negative 2 minus 4 is negative. Because all I care about is positives and negatives. So I don't really have to be too concerned about the numbers as long as I get the signs right. So negative 1, negative 6, that makes a positive number. But do I want a positive number? No, I want it where it was less than 0, so I'm not going to shade that region because I got a positive answer. If I plug in 0, I get 3 times negative 4. Right, I can deal with the numbers there because they're easy. But the point is that's negative, and I want it to be negative.
That was the ADA bill. Please take your ADA attendance at this time. Have a great day.
So I'll shade that region. If I plug in 5, I get 2 times 5 plus 3 is positive. And 5 minus 4 is positive. And positive times positive is positive. But I don't want the positives, I want the negatives, so I won't shade that region. So my region that's shaded is negative 3 halves to 4, including the negative 3 halves and the 4. So in my mind, the number line is a little bit tedious. If you know the graph, it's a little easier. But probably nobody knows the graph of number 4. Right? So number 4 is definitely going to be a number line problem because I have no idea what that looks like. Okay, so number 4. The nice thing about number 4 is it's already factored. So I've got some top zeros. X equals 2, x equals negative 6. Got some bottom zeros. X equals negative 2 and x equals 5. And again, I have no idea what that graph looks like, so I am not attempting to graph this. This is definitely a number line problem. I don't know how to say this without sounding condescending. When you put your numbers on the number line, please put them on in order. Right? Like that's the point of a number line, is it's in order. And yet someone, probably I would guess only one person out of, I don't have anyone in mind, but somebody among the 3 classes is going to put these numbers on the number line out of order. And that's really going to throw them off because the whole point of the number line is put them on in order. Now let's see if I can do that without making a mistake.
For the top rows? I thought that was an X out in front of the one.
Yeah, so be careful. If that was an X there, then you'd have x equals 0 as a 0, but not just a negative 2.
Negative 2 not do anything?
It doesn't do anything in terms of zeros, the negative 2, but obviously the negative on there changes the signs. So it is important, but it does not do anything in terms of what the zeros are. All right, open circles or closed circles? Trick question. Trick question. The top numbers are going to be closed because of the equal sign. So 2 and negative 6 are closed. What about those bottom zeros? Included or not included? And why are they not included? So you'll always exclude the bottom zeros. Always open circles for zeros of the bottom. Because you can't divide by 0. So it doesn't matter. The inequality sign doesn't matter at that point. You can't divide by 0. So the bottoms are always open circle. The top ones, well, it depends on if it's equal to or not. That's a lot of intervals to check. Negative 7, negative 3, 0, 3, 6. You can pick any number you want on the interval. You know, 0 is a nice one to pick. I usually try to pick the smallest number that's on the interval. Right? I don't want to pick 5 million. I don't want to pick pi, something silly. You know, 3/4. Pick something easy. And let's plug them in. So here's where that negative 2 definitely matters. If I plug in negative 7, again, I'm only looking at positives and negatives, so it's not as bad as it looks. Negative 7 minus 2 is negative. Negative 7 plus 6 is negative. Negative 7 plus 2, negative. Negative 7 minus 5, negative. And everybody knows that 5 negatives makes a negative. Okay, do I want a negative? Do I want a shade there or not shade there? Yes, because I want it where I want it to be negative. I want it to be less than 0. So I will shade that interval. All right, plug in negative 3. Okay, negative 2 is unaffected. Negative 3 minus 2, negative. Negative 3 plus 6, that's positive. Negative 3 minus 2 is negative. Negative 3 minus 5 is negative. 4 negatives and a positive make a positive. I don't want the positives, so I'm going to X that. I mean, I just leave it blank, but I put an X there, sort of note to self that I checked that interval and it doesn't work. 0 should be easy to check. Negative times positive over positive times negative. So that's negative. I do want it to be negative, so that works. This is a good time for me to take attendance for real. Alright, so in interval notation, from negative infinity to negative 6, include negative 6. From negative 2 to 2, don't include negative 2, do include positive 2. And then from 5 to infinity, but don't include 5. That one was kind of a pain, but it illustrates. Do you notice a pattern there of shading? Yes, no, yes, no, yes. The shading alternates. Yay, that's great. There's an exception though. So we need to be careful. You can use the alternating rule, which means you don't have to check everything. If you're confident that it alternates, and if you're really confident that it alternates, you check one interval and alternate off of that one. If you're not quite sure, and this is what most people do, they'll check like 2 intervals, make sure they get the alternating rule, and then they'll just alternate after that, rather than checking 5 intervals. Now, the exception is double roots. Actually, any even root, or even factors. Because at a double factor, the sign doesn't change. Right, you think about a graph bounces, it doesn't change. Or you think about the fact that it's squared, so it doesn't matter what's in there, it's going to be positive. So when you hit a double root, you don't alternate, you just do the same thing. It's either yes, yes, or no, no. Now, you can avoid the alternating thing altogether if you just check every single interval every single time. But most people, it's worth it to remember the alternating rule to save you the time. Alright, 5 looks terrible, but it's not really that bad because it's already factored. So I've got some top zeros and some bottom zeros. And that should be an easy popsicle stick. So, Tanner, give me the top zeros. I'll ask you for all of them.
0.
Uh-huh.
Negative 4. And 5.
Good. That's exactly right. That's exactly what I asked for. But I do see that negative 4 is a double root. So I don't have to flag that, but it might be helpful later to kind of make a note of that. Negative 4 is a double root. 5 is a triple root. So I don't have to say that, but it might come in handy later. David, how about zeros at the bottom? Good, 2 and 4. And again, x equals 2 is a quintuple root, and x equals 4 is a quadruple root. By x, I just mean 4 times. I don't know if that's a quint root and a quad root. So no idea at all what that graph looks like. That would be a crazy graph. So I'm definitely not going the graphing method on that one. This is number line for sure. Again, please put them on in order. They don't have to be spaced, like your scale doesn't have to be right. because all you're doing is setting up the intervals. So it doesn't matter that, yeah, my scale's way off here, because that should be 4 units, 2 units, 2 units, 1. That doesn't matter, though, because you're just setting it up to keep track of intervals. Bottom zeros I know are open circles. Always open circles for the bottom zeros, so 2 and 4 are open. What about the top zeros? Include or exclude? Include because of the equal sign. And then I think I'm going to make a note before I go any further that -4 is a double root, 0 is a single root, 2 is a quintuple root, 4 is a quadruple root, and 5 is a triple root. This is crazy. But that matters in terms of whether I alternate or not, because I really do not want to check 6 intervals. I'd rather use the alternating rule. So at a double root, I'm not going to alternate. At a single root, I'll alternate. At a quintuple root, alternate or not alternate? For a 5x, something that there's 5 roots there. Yeah, that alternates. That crosses the graph there, so I'll alternate there. A quadruple root, I will not alternate. And a triple root, I will alternate. I still gotta plug in something though to get me started. What value do you think would be best suited to plug in and check? I would go with 1. You could check the ends. Like some people like to check the ends because if you plug in 10, it almost always makes everything positive, although not so on this one. So be careful. Let's check 1, and then we'll just alternate off of there. So 2 times 1 is positive. 1 plus 4 is positive. Squared stays positive, so not worried about the squared. 1 minus 5 is negative. Negative cubed is negative. 2 minus 1 is positive. 2 to the 5th doesn't change anything. 4 minus 1 is positive. And 2 to the 4th doesn't change anything. So all of that to say, I get a negative for if I plug in 1. So is that a shade or a not shade? Not shade, because I want it to be greater than 0. So that's a no-go there. Okay. If I'm careful, I don't have to check any more roots or any more intervals, because I'll alternate across 2, so that's a yes on that side. I won't alternate across 4, so that stays a yes. And then I will alternate across 5, so that's a no. Then going back the other way, yes, because we alternate. And then no, we don't alternate, so that's a yes as well. So if I shade my yeses, whoops. And again, if you're not sure, then you go and check 6 and make sure that it's a no, like you thought it was. So interval notation, this is going to be fun. Negative infinity to 0, include 0. I can't go 2 to 5 because I have to exclude 4. So I'm going to go 2 to 4, and then 4 to 5. Again, that we did that the shortest way possible. If you get through and you're like, man, that was a whole lot of work. Let's check 6. I'm going to check 6 just to make sure I did this right. So if I plug in 6, I get positive, positive, positive over, 2 minus 6 is negative, to the 5th stays negative, 4 minus 6 is negative, but 4th it becomes positive. So if I plug in 6, I get a negative. I don't want the negatives, so I was right. I don't shade there. So now I feel much better about my solution. I think that's what most students do. Like, they use the alternating rule, but maybe you check one just to make sure. Certainly, maybe the first pass through the test, you just use the alternating rule and be done with it. Maybe you put a star next to it, and you're like, yeah, at the end, if I got another 30 seconds left, maybe I'll check 6 to see if I was right. All right, we're only going to do one more. Number 6. Remember step 1 was zeros of top and zeros of bottom? But that sort of suggests I need a top and a bottom, not two sides of an equation. So I'm going to move one of those to the other side. And then I'll get a common denominator. For both of those. So now this is starting to look more familiar. I've got a common denominator. Let's see if I can get my numerator all at once here. 3x minus 2x is x. And then 15 plus 4. Yeah, minus. 15 plus 4 is 19. Well, now I've got something that looks more familiar. So that one had an extra couple of algebra steps at the beginning. So Madison Hall, don't pick me. How about zeros of the top? What would make the top be 0? What value of x would make the top 0? Negative 19. Christian, how about zeros of the bottom? 2 and negative 5. So those set up my number lines, or my number line. And negative 19 is way out there, but again, I don't care about the scale, as long as I put them on in the right order. Negative 19, 5, and 2. I don't have any double roots to worry about, so it's going to alternate the whole way. What about open and closed circles? They are all open. The bottom's open because the bottom's always open. Negative 19 is open because it's not equal to. And then I only need to check one value because I can alternate. So given the option, I would check 0. Oh, this is another favorite error, is to check 0, but to have 0 in the wrong spot. All right, I will make fun of you in my head, not publicly. That's not nice. But if I see that if you've checked 0, but you've got 0 between negative 5 and negative 19, I will take a picture of it and send it to my math colleagues without your name. So, I'm making fun of you, but not by name. Try to tell myself that's okay to do. All right, plug in 0. I get positive over positive times negative. So that's negative. Is that good or bad? Like, do I want to shade for this one when it's negative? Yes, because I want to be negative. So yes, we will shade there. And which means we won't shade in the adjoining or the adjacent intervals. We will alternate from there. Again, trust the alternating rule, you're done. You don't trust the alternating rule, well, maybe you plug in 3 or negative 20 to see what happens. Negative infinity to negative 19, union with negative 5 to 2. It's a whole lot of algebra today. Nothing really hard, just a whole lot of algebra. Being careful, keeping up with all the signs, if there's a double root. So nothing's awful, just be careful. 7 and 8, very straightforward. We're not even going to look at those. And so this goes to worksheet number 3. Yes. We will have a quiz on block day, but we'll go over this worksheet before we do the quiz. And the quiz is over 1, 2, and 3.